Good day. Welcome to the Math Salon. I'm Dr. Anumendem. Today we are going to look at equation on integration. This is for the advanced levels. So the question says evaluate the integral of 1 divided by 1 minus cos theta d theta by using the substitution t is equal to theta of tan theta on 2. So the theta on 2 is in brackets, so it's the angle that is half of the angle, not the function. Same. So normally if I have to use this substitution, I have to use the substitution t is equal to tan theta on 2, then it means at the end of the day, everything I should have on this integral should be t, should be in terms of t. So I'll need to replace cos theta, I also need to replace d theta. In order to replace cos theta, we have this relationship that exists, but it's better we show how that comes about. So cos theta can be written as cos of theta on 2 plus theta on 2. That is correct. Half theta plus half theta is 1 whole theta. So if we use some of the trigonometric relationship that we know for half angles, then this is going to be cos theta on 2, cos theta on 2. This is plus here, minus sine theta on 2, sine theta on 2. If you arrange this properly, you get cos squared theta on 2 minus sine squared theta on 2. Of course, this is not yet in form. The only thing I can use is tan theta on 2, so I try to force tan theta on 2 here. Luckily for us, something like 1 can be written in different ways. I mean, that's why mathematics is beautiful. So as you get into a salon, you come back each day as a different person, but you are the same one. So 1 can also be written with this standard trigonometric identity, that is squared theta plus sine squared theta. So if I divide something by 1, it doesn't change. So it means I can write my cos theta as cos squared theta on 2 minus sine squared theta on 2 divided by 1. But I will put the special version of the one that just came out of the salon. So this is cos squared theta plus sine squared theta on 2. Still, I've not yet had the tangent form. So I know the tangent is supposed to be the sine over the cos. So if I divide all through by cos theta on 2, cos theta on 2 squared, then I should get some relationship there. If I divide it by cos squared theta on 2, I will get 1 here. Minus, this will be sine squared theta on 2, cos squared theta on 2. Divided by, if I divide this here by cos squared theta on 2, I get 1. Plus, this is sine here. Sine squared theta on 2 divided by cos squared theta on 2. So it means at the end I have here, this is tan squared theta on 2, this is tan squared theta on 2, and I can replace it with t. So this is now 1 minus t squared divided by 1 plus t squared. So just to indicate how this was obtained. Yeah, but my integral has 1 minus cos theta. So it means 1 minus cos theta will be 1 minus this. If I arrange this here, I have the LCM, or the lowest common multiple being just this one. Yeah, so this 1 plus t squared. 1 plus t squared divided by 1 is 1 plus t squared times 1, 1 plus t squared. This minus is there. The minus becomes to the minus 1 and changes this to plus. So the minus goes away with that, and I get 2t squared. 2t squared divided by 1 plus t squared. The function that I have to integrate is 1 divided by, so I take 1 all over that. If I take 1 all over 2t squared on 1 plus t squared, this is equal to 1 plus t squared divided by 2t squared. So that's why I have now this. So my integral, this integral that we are supposed to look for, is now 1 over that, but I still need to get d theta. So it was given to us that we could use this, t is equal to tan theta on 2, so that's my tan theta on school. If I differentiate, then I would use chain rule on this. So the function tan a squared, sec squared of that, theta on 2. But this is also a function. So if I differentiate this, I get half. And that's why I have the half outside, the d theta, of course. Now, but sec squared theta, I don't have anything about it. I have to try to make sure I get something in terms of the tangent. So I also know from the identity, let's say we look again at this special 1, and we take it to a different salon, it comes out also beautiful. So this is 1 is equal to, for example, cos squared theta on 2 plus sine square theta on 2. So in order to get tangent coming, I can divide all through by cos square theta. So I get 1 over cos square theta on 2 is equal to, this is 1 here in this position, sine square theta on 2 over cos square theta on 2. And this is sec square theta on 2, and this is equal to 1 plus tan square theta on 2. So it means I can replace this here with this here in the brackets based on that. If I do that, now I'm fine. I get a relationship that has something to do with t. So I can put my t there is squared. So the 1 plus t squared divided by 2 d theta. I make d theta the subject because I have to substitute here. So I divide all through by that. The 2 goes up and the 1 plus t comes down. If I do that, now I have all the ingredients required. So I'm just left to substitute. And this one goes off with that, and this goes off with that, and I get this. And if you integrate it, it's just t to the minus 2. And by integration, you have to increase the power by 1 and divide by that. So this is that divided by minus 2 plus 1. So this is minus 1 below, and get that. Plus a constant, because this is an indefinite integral. So I hope you like it. And if you did, please just give us thumbs up. And most especially, remember to subscribe. We are glad when we see many people subscribe. That gives us the motivation to continue doing this. Have a nice day.